Anastasia.
Hi, I'm Nicole.
Over the 2-day period, we're making a crystal through nucleation and crystallization.
The materials that we'll be using today include glass jar, fishing line, potassium aluminum sulfate, glass bowl, a pen, a knife, paper towel, and a kettle for boiled water.
During the first day, the first step is to boil 1/4 of a cup of tap water. Step 2 is to add potassium aluminum sulfate to the boiled water in the glass jar until it is saturated.
Step 3, pour 1/8 of the solution from the glass jar into the glass bowl through paper towel filter. Step 4, leave for a day, then you'll see crystals forming.
There's antimony, arsenic, aluminum, selenium, and hydrogen and oxygen and nitrogen and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, protactinium, and indium, and gallium, and iodine, and thorium, and...
During the second day, step 5, pick out the biggest crystal from the glass bowl.
Step 6, wrap a string around the biggest crystal chosen and attach it to a pen.
And iodine, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and
Step 7. Boil half a cup of water and then add potassium aluminum sulfate for saturation in a glass bowl.
Step 8. Filter the solution using paper towels into a glass jar.
Iridium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, bromine, lithium, beryllium, and barium. There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine and terbium and manganese and mercury, molybdenum, magnesium, dysprosium and scandium and cerium.
Step 9. Suspend the crystal in the filtered solution. Then cover the top of the jar with paper to stop dust from entering. Leave the crystal for a day and watch the crystal grow.
Step 10. Take the crystal out of the glass jar, place it onto a plastic lid, and let it dry.
Cerium and cesium and lead, praseodymium and platinum, plutonium, palladium, promethium, potassium, polonium and tantalum, technetium, titanium, tellurium, and cadmium and calcium and chromium and curium.
The science behind it. The crystals formed during the experiment undergo a process called crystallization, which is a process of formation of a solid crystals precipitating from a solution.
During the first step, the crystal undergoes a process called nucleation, which is the initial process that occurs during the formation of a crystal from a solution.
The alum molecules group together in a crystal pattern. As other alum molecules bond to it, this will create a visible crystal molecule, also known as a seed crystal.
By choosing the biggest crystal, we create a new nucleation site, which is the primary location for the alum molecules to join together. This is done to create a larger crystal so that alum molecules do not compete with each other.
Lastly, the crystal is also known as aluminum sulfate. It is used in water purification, which causes impurities to coagulate.
There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, krypton, neon, radon, xenon, zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard. And there may be many others, but they haven't been discovered.